A random variable is normally distributed with mean 85 and standard deviation 5. In other words, x follows a normal with mean 85 and variance 5 squared. Using the 68, 95, 99.7 rule, estimate the following. The first one being the probability that x is between 80 and 85. I'm going to draw a sketch to help me with this. And here's my distribution. And the mean here is 85. And so one standard deviation down is 80. One standard deviation up would be 90. And then I'll have 75 and 70 and 95 and 100. And in this third part of the question, we're after this. Now, what we know is that if it was the whole of this, then we would be talking about 68%. That's the part of the rule. We also know it's symmetric. So this bit that we actually want is half of 68, which is 34%. As a decimal, that is 0.34. So, moving to the next part, between 75 and 90. So, between 75 and 90 is this plus this. And just as it worked out in the first part of the question, this bit would be 0.34. Now we know that within 2 standard deviations we get 95, and half of that is 47.5%. So this bit, all of that bit from 75 to 85, would be 0.475. So adding those together gives me 0.815. Now we want the probability that x is greater than 95. So let's just remove some of this from my sketch. I could produce a new sketch, I guess. And let's just put that line back in that I accidentally deleted. So greater than 95 would be up there. Now, 95, that's 2 standard deviations up. If we also considered this bit here, because we know in between 75 and 95 must be 95, that tells us there must be 2.5% at either end. So this is going to be 0.025. Finally, we want the probability that x is between 90 and 95. So that is going to be this bit here. Now we know from earlier in the question that all of that would be 0.475. We know that this bit is 0.34. So the part that we want is just going to be 0.475, take away 0.34. And that gives us 0.135.